moving from a sedentary to a physically active societal way of life. This is...
Welcome to the premiere episode of Up on Our Feet, the first in an ongoing series of interviews, discussions, reports, and other formats that deal with the issue of moving from a sedentary to a physically active societal way of life, especially as this relates to education, health, the environment, and the economy. And for this premiere episode, we're pleased to have as our guest Professor Charles Hillman of Northeastern University in Boston, an internationally recognized neuroscientist whose research specializes in the connection between physical activity and cognition, including how physical activity impacts students' academic performance. Professor Hillman is also a member of the American Sports Institute's International Board of Advisors. Professor Hillman, nice to have you with us.
Hi, Joel. Thanks for having me. It's great to be here today.
Thank you. Okay, so let's start off. Most people may not be familiar with the term or the field of neuroscience. What is neuroscience?
Yeah, thanks, Joel. Neuroscience is simply the science of the nervous system, which includes brain and spinal column for most part.
Okay, and then your particular area is, or one of your specialty areas is physical activity in the realm of neuroscience. I imagine there are other fields of study in neuroscience?
Absolutely. I mean, neuroscience is a huge field. It includes cognition, which is my area, affect and emotion. So it's affective neuroscience, social neuroscience. There's basic neuroscience where people, use animal models, and physical activity is crossed into many of these different areas.
Okay. So what was your journey? How did you end up with neuroscience and physical activity?
Yeah, I mean, that's a long answer. To tell you how far I came, my master's thesis was on the psychophysiology of sports fans, and looking at emotional responses. And you can actually go back to, I think it was 97, and look up, I was covered in Sports Illustrated. But anyway, back then, neuroscience wasn't really a field as we discuss it today. I mean, the field was psychophysiology, which was sort of the roots of neuroscience. And I was starting to study brain back then using EEG, but was also saying a number of peripheral measures and reflex measures like the sorrel reflex and heart rate and skin conductance. But eventually found my interest in cognitive aging and was interested in how older adults, as part of the natural aging process, their brains slow down. Memory complaints are frequent, and it can be pathological as well, leading to diseases like dementia or Alzheimer's disease. And so my actual dissertation back in 99, 2000 was on the effects of physical activity, cardiorespiratory fitness on cognitive aging using neuroscience tools. But then it was somewhere around 2002, 2003 that I sort of flipped the question and started to ask about questions around whether physical activity and aerobic fitness could improve cognitive function and underlying aspects of brain function in children.
Okay. And so I assume, and we're getting ahead of ourselves a little bit here, that's what led to eventually your work with academic achievement?
Yeah, so actually, I have to give a lot of credit to Darla Castelli, who's now a professor at the University of Texas at Austin. But Darla and I were both at the University of Illinois at the same time. We bonded over not just science, but we're fellow New Englanders. And and so when I went to her, because I really didn't know a whole lot about studying children, we began to have discussions, and she got fascinated with my neuroscience approach and my cognitive approach. And I got fascinated with her approach to studying student achievement. And so we found ways to combine all of that and at times to integrate those various outcomes into coherent stories.
Okay. All right. So we're going to get to academic achievement in a few minutes, but let's back up here. Just how does how does physical activity impact the brain? What's the process? How does that happen?
Yeah, Joel, that's a good question. And quite frankly, we know somewhat what goes on, but it's not a single pathway or a single mechanism. We could talk about this from a molecular and cellular perspective. We could talk about it from a systems perspective, brain structure, brain function, and so forth. And so I guess, we know that there's a number of, molecular aspects of brain that are affected by physical activity and other lifestyle factors, right? Diet, nutrition, things like that. And so, at that level, we're seeing changes in neurogenesis and the formation of new neurons, angiogenesis, the formation of capillary beds that bring blood flow to neurons. We see changes in growth factors like brain-derived neurotrophin factor that are that feed that provide the environment in which to grow or which to have genesis occur. We see effects certainly at the cellular level. We know that, for instance, great animal work from the 80s by a guy named Bill Greeno, who's since passed. He showed that if you give rodents access to a running wheel, they exhibit angiogenesis in the cerebellum, so they have greater blood flow to keep up with that metabolic demand of adding exercise into their lives. But if you give them what I like to call sort of like rodent Cirque du Soleil, right? We have them, he would have them like walk on tight ropes and climb ladders and attach weights to their back. And they learn all these different aspects of motor skill and motor, performance. They didn't exhibit angiogenesis. They exhibited synaptogenesis. So the neurons in the cerebellum would, had more branching and could speak to one another, transmit information to one another more effectively and more efficiently. And so different types of exercise have different effects on cellular aspects of brain. Now, work in humans doesn't go to that level. I mean, we don't get a lot of offers to allow us to have a piece of tissue from people's brains. Instead, we have to use imaging tools. And so early on, we used EEG and an area of EEG called event-related brain potentials to look at the electrical system of the brain. I still have a line of research that's interested in that area. More recently has been the advent of using MRI and functional MRI in order to measure brain structure and brain function, using where we can get a much holistic understanding of what's going on instead of just looking at little aspects of brain tissue. And then others have used PET and MEG and all kinds of imaging devices. And then lastly, behavior. I mean, we can infer what's going on in the brain from well-designed behavioral studies or cognitive studies where we can, use manipulation, in this case, exercise exposure, and look at how certain aspects of cognition change and not others. And from that, we can infer areas of the brain that are involved.
Okay. So you've just talked about a number of things and a number of areas of the brain that are affected by physical activity. Would you just say a few words, because I know the hippocampus has a lot to do with learning and memory, and we're going to get into the issue about kids and academic achievement. Would you say a little bit about how physical activity impacts the hippocampus, where the hippocampus is, because probably most people have never heard of it?
Okay. Well, Joel, that's a good question. I mean, the hippocampus is probably our most researched area of the brain when it comes to physical activity across humans and non-human animals, such as rodents. Rodents have well-developed hippocampi relative to other regions of their brain. If you were to put your fingers in your ears, the hippocampus is where they would meet, in the middle of the brain. So it's a subcortical structure sitting down, in sort of the deep depths of the brain, right kind of in the middle. It gets its name because it's somewhat horseshoe shaped. But anyway, the hippocampus has demonstrated that it is amenable to physical activity or exercise interventions, both from a structural and functional perspective. Meaning that through exercise intervention, we could influence both the size and shape as well as how the hippocampus functions. Hippocampus is important because in rodents, as I said, it's well developed. It's involved in aspects of memory, particularly associative or relational memory, as well as a whole bunch of other functions of cognition. And it's important in humans because there's rich tracks that connect the hippocampus to all kinds of different areas of the brain, including the prefrontal cortex, which is really important for humans. So if I were to step back and talk about associative memory or relational memory, this is the type of memory that's involved when we're trying to understand relationships in our environment. And so if you think about, the small rodents, maybe a mouse out in the wild, they're hiding in their hole, but they got to come out eventually because they got to eat. They got to, they're genetically, genetically programmed to want to mate and whatnot and to socialize. And so what they want to do is they got to get out of that hole and they got to go find food. They got to go find their mate, things like that. But they also got to know where their hole is, where the predator is, and all of this happens in time and space. And so the hippocampus comes online to form relationships in the environment so that in this case, that tiny rodent can remember, okay, I better not go left because I know that there's a cat that lives over there. And, but if I go right, I know that there's, tasty food over there. And so it's very important from that perspective. In humans, the hippocampus is equally as important, but it's also important for higher order aspects of learning, like scholastic performance, which we'll get to in a little bit.
Mm-hmm. And would you say a few words then, because we're going to get right into that, also about physical activity and executive functions and just what are executive functions?
Certainly. So I mentioned the prefrontal cortex a minute ago, and the prefrontal cortex and its associated network is important for executive functioning. Humans have, really the most developed prefrontal cortex of any species on the planet. And that's where most of our higher order cognition occurs. And so among those higher order aspects, cognition is executive functioning. This is our ability to perform the intentional components of our actions within the environment, meaning that we're acting at a will, not at a reflex. And so, this is important when we have goal-directed actions. You may be hungry as lunchtime's approaching, and you're going to plan, to get in your car and drive to, Whole Foods and, go pick up a sandwich at the deli, right? And that all involves executive action, right? You have to, you have goals, you have to achieve those goals, you have to figure out how you're going to get there, you're scheduling and coordinating and all these sorts of things in order to make it reality, right? And so executive function is commonly decomposed into three areas of cognition. One is inhibition, which is our ability to ignore distractions, stay focused on relevant aspects of the environment. The second is working memory. This is our ability to hold information in our mind, manipulate it, and then use it when appropriate. Obviously, this is also very hippocampally dependent. And then cognitive flexibility requires multiple aspects, not just the ability to be mentally flexible. It also involves inhibition and working memory, because it's the idea that we're going to hold information in our mind, we're going to execute a task based on the demands of that task, then we're going to inhibit that task, we're going to go to a second task, we're going to execute that task based on a different set of mappings and instructions, we're going to inhibit that and go back and forth. And this is often what we call multitasking, right? This is our ability to, say, drive and text, but we know we don't do that very well, right? And so the moral here is that while cognitive flexibility is an important aspect of executive function, there are very, very few people that are able to do two tasks as well as they can do either task separately.
Okay. All right. So let's take all this. We've got executive functions, we've got the hippocampus, we've got physical activity, we've got rodents running around figuring all these things out, and we've got kids running around on our schools. And so how does all of this, the hippocampus, the physical activity, the executive functions, how does this all come into play with our kids, their academic performance, and their social emotional states in school?
Yeah, Joel, I mean, that's a really good question. I'll tell you up front, I don't have a great answer for you. I mean, we're basically I have a few things I can say. I guess I'd start from a more of a perspective on our species and our history as a species. We weren't always sedentary. We are now sedentary as a species. We've known this for several decades. The human genome was developed in concert with movement and is dependent upon movement. And so from a metabolic perspective, we're at a mismatch between our human genome and how we live our lives. And because of this, we have a pandemic of obesity, which has been around long before the pandemic we're all talking about now. And we've had a pandemic of inactivity. This relates to not just obesity, but to metabolic disorders. And this is all stuff that actually our mutual friend, Fernando Gomez-Pania, would be probably thrilled to talk about. It's right in his area. And so, what we're looking at here, in my view, is a species, and in this case, children of that species that are not adequately physically active for the most part. And so, really what we're talking about is maybe, less optimal cognitive performance from where we could be. And so when we introduce physical activity into their world, which oftentimes now is forced in some regards, I'll use force loosely, we're able to benefit their cognitive functions and ultimately their academic performance. So that's one piece of it. We know that executive functions heavily underlie academic performance. So children who are better executive functioners, better inhibitors, better with working memory, better cognitive flexibility, are better in school. Kids who can inhibit inappropriate behaviors, they learn better. Kids who can carry the remainder and hold that in working memory, they perform better math, right? Or if they can hold a passage in their mind and answer questions, they perform their reading comprehension better. So they're better performers. And knowing that physical activity benefits those aspects of cognition, what it ultimately leads to better overall performance as well. Now, one of the problems we have is that the physical activity literature in this area is underdeveloped. I mean, it's a work in progress, right? There's some evidence that physical activity benefits scholastic performance using randomized controlled trials, but there's other evidence that doesn't. And that, we could have a whole hour-long conversation about why that is, but briefly, lots of, not all studies are created equal. So, there's differences in intervention, there's differences in the types of outcomes they use, there's differences in the physical activity dose that's being used. And so until we clarify that, we don't really know just how robust this relationship truly is.
Okay, so our viewers may not know this, but I know this, and you've done extensive studies on the correlation between physical activity and academic achievement. You, without trying to embarrass you, you're highly praised throughout the community as to your work. I know people where you've traveled to their countries to make presentations and things like that. Of the studies you've done, putting all your knowledge and skills into doing peer-reviewed studies that stand the test of time, what do your studies say regarding the correlation between physical activity and academic achievement?
Yeah, well, thanks for that, Joel. I mean, I guess I'd say, I represent a strong group of scholars, and I'm fortunate to be able to represent them here and elsewhere. So our work, we can really break it down to two areas. If we're just going to stick to physical activity, obviously, there's other lifestyle factors I like to talk about, like obesity and things like that. But when it comes to physical activity, we can talk about two areas. We can talk about randomized controlled trials that, where we take children, they get randomized to either a physical activity group or a control group, and we look at post baseline to post test differences in cognition and aspects of brain. Or we could talk about what's the effect of a single dose of exercise. That is, we give kids a single dose of exercise. What's the temporary improvement in cognition look like in brain function and academic performance? And so if we take the first area, what we know is that from the work in my laboratory, we've run 2 randomized controlled trials, RCTs, called Fit Kids and Fit Kids 2. I'm very original in the second one. And we've shown that 6 months of physical activity interaction, which, just to give a dose to that, was 5 days a week for 2 hours after school for 165 days out of 180 school day, 180-day school year. So it's a strong dose. We've shown that there's benefits to that intervention. There's efficacy in the intervention because we see increases in cardiorespiratory fitness from pre to post. And what we find is again, we see changes in brain structure. We see changes in brain function. We see changes in cognition. At times we see changes in academic performance, but it's clearly not as strong as those other changes, okay? There's several reasons for that. One is that academic performance is a much more complex area to measure. So, when we take a laboratory task and we boil it down, we're controlling all aspects of that task, or as many aspects as we can. It's a bit contrived, and we have strong internal validity on those measures, but poorer external validity. When we measure academic performance, we lose a little internal validity and we gain a little external validity, but it's not as easy to measure it because what goes into math or what goes into reading is a whole bunch of different functions. We're not just looking at executive function or maybe 1 or 2 aspects of executive function. There's all kinds of other stuff that goes into that, attention and memory and perception and and whatnot. And linking that back to the brain is equally as difficult. Although we have done that, we've been able to do that on certain occasions. And so, if we were to think about, well, why don't we take multiple aspects of academic achievement? Well, that's hard. I mean, there's standardized achievement tests, more internal validity. People would argue it's not the best measure of what children actually, have learned in school. It's good, it's good, but without being great. We take teacher grades, which is a really good indicator of how they are day to day, but that's not without bias also, right? And there's all kinds of studies showing that teachers, teachers' biases involved, and kids have their own biases and parents have their biases and whatnot. And so it's a more complex area to study. Now, if we go to acute bouts of exercise, we see a much stronger effect.
And acute means, again, single
dose.
Right.
Yeah.
Not ongoing.
No. And so what happens there is we take a child and we walk them on a treadmill in most cases for 20 minutes at a moderate pace. In my 15 years or so of doing this line of work, a little longer, we never had a child quit. It is not a hard dose of exercise.
Yeah.
I would probably equate it to the speed in which they would walk to school if they, knew they had to be there, but they didn't have to rush, And we've also at times started now to use high intensity interval training as well. And that's a much shorter dose, but high intensity. And we're seeing benefits to both for academic performance. Time and again, we've shown that a single dose of physical activity benefits math and reading achievement within the hour following the cessation of the dose. We've shown this in typical kids, healthy kids a few times. We've shown this in special populations like children with ADHD. We see the same benefit. And even my colleagues in Australia have shown some benefits of this as well, both long-term and acutely.
So when you can control the variables in the study and you can work directly with the kids as you're talking about the acute bouts where it's right there, and then you measure right after that the effect of the physical activity on their cognition. What's the time? I mean, is it 1 hour after they've done the physical activity where these benefits show up, or how long does it take?
Yeah, so we're actually learning a little bit about how long it takes. We used to think it happened immediately after, That's because, we used to rush and get an electrode cap on their head, which took about 15 minutes. And now we started to put the cap on ahead of time and just secure it in place. We've actually shown that in the first 5 minutes, we don't see as large a benefit as we have when we were testing in 15 minutes after. So I can tell you that the effect from the dose we deliver, the effect lasts approximately an hour. But when it begins, somewhere in the first 15 minutes. So if we're to take kids out and say move them around the yard and have them out in recess and have them exercise, they would then have to get back into the classroom and sit down in their seats and wait for the lesson. And that's probably about the right amount of time if I were to wager a guess.
Got it. Okay. So knowing all this, with schools cutting back on physical activity because their feet are held to the fire regarding standardized testing, et cetera, in a way, are the schools working against the best interests of the kids and their own accountability by not having the kids engaged in more physical activity during the school day? Is that where all this is leading?
Yeah. Look, I'm not a pedagogist. I'm not an expert in schools and, and education, but from my perspective, it's time to update our school curriculum. And in my view, if I were an administrator of a school and genuinely interested in getting the best performance out of my students, there'd be time for physical activity and probably music and the arts every day, because I know there's benefits to music as well on brain and cognition and what have you.
Yes, we've talked about that.
Yeah. And so, off the top of my head, I mean, if it were me, I'd probably have a 45-minute lesson followed by 10 minutes of physical activity, followed by a 5-minute cool down, then start the hour again. And I would operate like that throughout the school day.
And as you probably know, you've been to University of Jyväskylä several times in Finland. In Finland, at the elementary school level, for every 45 minutes of academic classroom time, it's mandated that the kids get then 15 minutes of physical activity outside. So that's really what you're talking about there.
Absolutely. I mean, I think that Finland is doing it much better than other people. Denmark does it quite well too. But Finland, and particularly, the exercise science folks at the University of Jyväskylä, they really know what they're doing. That's a very strong program, and there's great data coming out of there by several of them, showing that not just cardiorespiratory, but also motor, right? I mean, motor performance or motor skill development has a great effect on these factors as well.
Okay, final question.
Sure.
How many years have you been involved with neuroscience and physical activity? Rough guess.
Well, that's funny because I actually was just asked today how long this is. I'm about to start my 22nd year as a faculty member. And you can add a couple years on as for my dissertation time too.
All right, so let's give you a quarter century there at least, okay?
What it was, yeah.
Okay, and you've probably been involved with, I see you all the time on ResearchGate, which is the LinkedIn for researchers. You've probably been involved with hundreds of studies. Is that safe to say?
Yeah, I've published somewhere just shy of about 300 journal articles.
Okay, 300, 25-year, quarter century, and 300, at least 300 studies. When you're sitting around and you're not rooting for the Red Sox game isn't on television, and you're thinking about your work, what's the big picture message you're getting from all the years of your work and all the studies and the results you've gleaned from those studies? What's the big picture message there?
Yeah, we need to live more healthfully than we have before. I mean, we as a nation, we as a species, used to have to spend energy to get energy. And this is, again, going back to really one of my favorite papers by Fernando Gomez Pinilla called Revenge of the Sit. And, really what it's come down to is, as a species, if we were hungry, we had to go spend our energy to find something to eat. And when we did, we consumed a lot of it, but it wasn't unhealthy foods. Mm-hmm. And now, we spend very little energy. We type a few buttons into our phone and magically pizza arrives at the door and we're eating these, we're still binging, and we're binging on high caloric, high density foods. And, when you match that with a real lack of physical activity, we're becoming unhealthy. And so, probably after say 25 years of this, I'm always happy to talk about what this study finds and or the newest study finds, or, how this should be implemented. But honestly, at the end of the day, I'm thinking about myself, which is, I know selfish, but, I eat, I try and eat well. I exercise as many days a week as I can. I love to say I do every day, but, I'm a little older and I still love, combative sports like, ice hockey and mountain biking. And my body doesn't like that every day, but at least, I still walk to the train, which is, about a mile walk each direction every day I go into work. And, so I'm building as much physical activity into my life as possible. Sure, I'd love for it to be organized and planned, but at the end of the day, if you can just get incidental physical activity, park at the end of the parking lot instead of the closest possible spot, take the stairs instead of the elevator. These are all things that can help accrue physical activity into your day. And that's actually one of the messages of the physical activity guidelines for Americans that came out in 2018, which was that we no longer have to do this in 10-minute doses, but we can try and accrue as much as possible throughout the day in order to meet the guidelines.
Right. And when you say health, you're not talking just about physical health. It's both physical and mental, including the brain and cognition and things like this, right?
Absolutely, Joel. In fact, I would argue that's more important. If I have to lose one or the other, I'd prefer to be clear-minded and probably not have as much use of my body as the other way around.
Okay. Professor Charles Hillman of Northeastern University, thanks for being with us on Up on Our Feet.
Thank you, Joel. It's great being here today.